Hi, in this lecture we'll be discussing about the main difference between CPM and Pert. CPM is also called critical path method. Pert stands for program evaluation and review technique. So both these techniques which uses the network, either AON network or AOA network, using which will be able to find out the time of completion of the entire project. We can also identify the critical path, the activities which are non-critical. So in both sides, CPM or PERT both uses the network for finding these important parameters. Now, CPM use one value of time activity because the CPM is normally used for the project which is deterministic. Example, in the case of construction projects, the shipbuilding or the construction of different mechanical or biomedical or electrical equipment. In such cases, the project durations, the time which that takes for completing each activity is well known. In such cases, we can go for the CPM network. But in the case of PERT is a probabilistic approach, which means we are not very sure about the actual time which required for completion of a particular activity. In such cases, for example, the research and development activities, developing a new device or technologies, developing the satellites and so on. In such cases, always there is a kind of uncertainty. So when there is an uncertainty, we used to go for PERT analysis, and when there is certain that, or we are sure about the activity time, in such cases we go for CPM. So in the case of CPM, we use only one value of time activities because we are really sure about the activity time based on our previous experience. Now, in this case of PERT, since we are not sure about the time estimates or the time, so we go for 3 time estimates, which normally called as the optimistic time, pessimistic time, and mostly likely time. So based on the 3 activities, we are supposed to calculate the expectations or the mean value of time as well as the variance value. So in the case of CPM, which is based on single time estimate, whereas in the case of PERT, it is calculated, the activity time is calculated based on the 3 time estimates, and from that we are supposed to calculate the mean value and variance of the time. Now, the main purpose of the CPM is used to minimize the cost. So when there is a cost minimization, we normally go for what we call the CPM network. But the PERT normally meeting the time target, or it helps us to find out the percentage completion of a particular project. So in the end of the PERT analysis, we'll be able to tell that what percentage chance that a particular project that can be completed within X or in a specific time. For example, what is the probability that a particular project that can be completed in 24 months? We can say that whether it is 90% or 95% or something. But in the case of CPM, we can surely say that this project will be completed within 45 days because since we are certain about it. So this is the main difference between the CPM and PERT activities. And normally in the case of PERT, we're supposed to use the normal distribution graph because we'll have something called the z-score, and from the normal distribution table we're supposed to find out the probability. But in the case of CPM, directly from the network graph we'll be able to find out the time of completing this job. So PERT normally, as we said, PERT normally for dealing with uncertainties. So we have 3 basic time estimates. First time is called the most likely time estimate, and other time is called optimistic time, and the third time is called pessimistic time. The expected value of the time, which is also called the mean value, that is calculated by using the equation A, which is the optimistic time, then B, which is the pessimistic time, and 4 times the most likely time over 6. Same way, we can also calculate the variance. The variance is calculated by the equation the pessimistic time minus the optimistic time divided by 6, the whole power, to the power 2, or the square. So B minus A divided by 6, the whole square. Then standard deviation is nothing but the square root of variance. Now let us look at an example here. So here a project activity and different times are already given. So these are the different activities, A, B, C, D up to J, and these are the immediate predecessor. So this means that activity A is a starting activity. There is now no predecessor, or there is no activity before A, B and C, whereas for D, A has to be completed, E, B and C has to be completed, F, B and C has to be completed, G, B and C has to be completed. The activity H requires C, activity I require G and H, and activity J require D and E. And we can see that there are 3 different time estimates out there. So which means the optimistic time, and this is the pessimistic time, and this is the most likely time. So the optimistic time normally is less than the actual time, because and similarly the pessimistic time normally it is the higher estimate of the time, whereas the most likely time is something like a median time. So in order to calculate the expectation or the mean value, you're supposed to add the optimistic time and pessimistic time, then 4 times the most likely time divided by 6. If you do that, we'll get this number is equal to 20, which means 10 plus 22 plus 4 times 22 over 6. That will give you the expected time, which is also called the mean value. So by using the equation, we can calculate the mean value for the entire the data. So similarly for the second code, 20 plus 20, which is 40, 40 plus 2 times 20, which is another 40. So that is going to be divided by 6. So 20 plus 20, which is 40. Then 4 times 20 is going to be 80. 80 plus 40 is like 120. 120 divided by 6 is going to give you 20. So likewise you can calculate this one. Then the variance that is calculated by the equation, as we already said, B minus A divided by 6, the whole square. Then you can go for the standard deviation, which is nothing but the square root of the variance. So how to calculate, or how to draw the how to estimate the time of completing this particular project from the network graph? The first job is that we have to draw a network by considering the activities and the predecessor. So we can see that here this is an activity. This type of graph is also called activity on arrow, because the activity is taking place exactly on the arrow. So this is an activity A. So here the network diagram, the numbers within bracket indicate this is the mean value and this is the corresponding standard deviation. So first job is, based on the given details, we have to draw the network diagram. Then mark all the activities and the 2 readings, which are the expected value or the mean value and the standard deviation. Next job is we have to find out the critical path. So the critical path means these are the activities which is no way that can be controlled, or if you are touching this particular activity, the whole project will be delayed. So if you can see here, this particular activity which is take 20 hours or 20 days. So the end of this particular activity by 20 hours, this activity will take another 15 hours, which means that the activity D will be finished at the end of 35 hours. Or by 35 hours, the activity D will be completed. Then followed by 8, which means what? 43. So you can say that the critical time for this particular activity is 43. You can also flow through other different channels or different paths. So here is 20 plus 30, that makes you 30. So here we have 30 and here we have 35. So definitely this particular activities, this particular node or the particular activity J, since it is required D as well as E, so we have to wait until 35. So this particular activity become a non-critical activity. Now look at this particular path. Here is 10 and here is 11, that makes 21. And this particular activity, which is already require 24 hours of time, as a result, this particular path is going to be non-critical activity. So in short, we can say that there is only one particular path which is critical, which is 1, 2. The path is like what? Or the activities like A, D, and J. And all other activities are non-critical activities. So the time which the particular project that can be completed, or the critical time, is like what? 43. And again, this particular time is nothing but we have calculated based on the 3 time estimate. So based on that, we are going to look at different activities and the latest start and earliest start. We can see that the activity A, it is starting from 0, 0, which means that the slack or the float or the 0 time between these two activities is 0. So ES minus LS will get you slack is 0. So which means that this is the significance, or this is the characteristics of a critical activity. So a critical activity can also be identified by looking at the early start and the latest start. So if the difference between ES and LS, if it is 0, such activity is also called critical activity. In this particular example, we can see that the activity B, latest start is 1, whereas the earliest start is 0. So which means there is a slack, which means 1, which means that this particular activity, it is possible to delay by 1 hour or 1 unit. In this case, it will be 4. So since there is a slack of 4, this activity becomes non-critical activity. And here this particular activity is, the difference is 0, so it's going to be a critical activity. So there are 3 critical activities are there, which are A, D, and J. You can see from this particular network graph, A, D, and J. Now once you have done that, we are supposed to calculate the C-score. So already from the earlier graph, the network graph, we found that the critical time is 43. Again, as we have said before, this 43 is not certain, or we are not sure about the total project duration is the 43 hours, because we have calculated this time based on the 3 time estimate. So we should find out what is the probability that this particular project that can be completed in 50 days. So what is the probability that this particular project that can be completed in 50 days? In order to do that, we are supposed to calculate the C-score. So the C-score is calculated by the equation D minus S divided by root V, where D is the scheduled date. So in this particular case, which is 50 days, for the date that we are expecting in this project that is to be completed, or this is our target date. You can say this is a target date, which is D is equal to 50. Now the S means the scheduled date, and from the graph, the network graph, we found that it is 43. And the next thing is the variance of the critical activities, because we know that there are 3 critical activities, and we are supposed to add the variance of these 3 activities, which is 25 plus 4 plus 4, which will give you 33. So it's supposed to substitute this value d minus s divided by root v, which is 50, which is the target. S means the scheduled date divided by root v. Root v is the variance. So if you substitute that, we'll get value 1.22. 1.22 is the z-score. Then the next step is what? We're supposed to use a normal distribution graph for the table, and from that we're supposed to find the value that is corresponds to 1.22. Now we can go for the standard normal distribution graph, and from this graph we get the value z-score, the value that corresponds to z-score 1.22. So from this column we can take 1.2 and plus 0.02. So 1.2 plus 0.02 will give you 1.22, and the value correspond to that is 0.8887, which is nothing but 88.87. So the value correspond to z is equal to 1.22 is 88.8, which means that 88.8% probability that, or the chance that this particular project that can be completed in 50 days. Now sometimes it is required to find out, in order to have 95% assurance that this particular project that can be completed, in how many days. Okay, so it is required to find out how many days it will take this particular project, such that the probability of assurance of the completion is 95%. So in such cases, we're supposed to do a reverse process where we have to find the z-score or the z-score corresponding to 1.645 from the same normal distribution graph. So the z-score corresponds to 95% approximately, which is 1.6 plus 0.05, 1.6 from row and 0.05 from the column. So we have 1.65 approximately. Now in this case we're supposed to assume that this value is 1.65 or 645, because the actual value is 1.645, but we just calculated from the table like 1.65. Then in this case we should calculate how much will be the value. So we have to do the reverse process, as we know that we have calculated z-score using the equation d minus s divided by root v, where d is the target dates and s stands for the scheduled date. So we're supposed to find out the value of s from this, because the scheduled date, so not the scheduled date, the date of completion of the project, which is d. So d is calculated by the equation the scheduled date plus 5.745 into 1.645. So this is the variance value, root v value, and s means the scheduled date. Already we found it is 43, and 1.645 is the value that correspond to the z-score 95 percentage value. So we'll have 43 here plus 9.45, which will give you 52.45 days. So this means that there is a 95% chance of finishing the project by 52.45 days. So as per the plan, as per the network diagrams, we calculated the time is 43, which is really less than the actual time of completion of the job, because we have seen now in this particular calculation that 95% chance that this project that can be finished in 52.45 days. So in order to complete this project in 100% accuracy, definitely this time will be much more than 52.45. So in short, the PERT analysis will give you the probability of completing a particular job, but it's not giving you any kind of assurance that this particular project that is completed within a estimated time.